thank you for your patience. Alrighty, so we are the bottom of page 141 for you, and it's just then the measuring of pH. How do we do it? So it's universal indicator, and this is just an FYI. So universal indicator is actually a mixture of indicator, and the colour is pH dependent. Whereas this is the other thing that you can see if you ever go into a biology lab and even a chemistry lab, because they'll make buffers in chemistry too. So pH meter, and it literally measures pH and it gives it a numerical value. So this measuring pH question, Dan, would be more likely to be asked in ordinary level than it would in higher.
Sorry, just taking. Oh.
Okay, you happy, Dan?
Yep.
Alrighty, so we're going to see, can we get into the maths?
Oh, I didn't write anything yet, so please move back.
Okay, I'm going to see, can I find... No, that didn't do it right. Share screen, pause share. I'm going to find the other thing that you need.
This animation demonstrates the difference between a strong acid, hydrochloric acid, and a weak acid,
Okay, can I change my share?
You can.
Thank you. So, new share. Why are you not seeing it now? This is the one I want. Okay, so I'm going to play this for you.
Hydrochloric acid is a strong acid. Strong acids are strong electrolytes, which for most purposes are assumed to ionize completely in water. In this case, HCl ionizes completely to hydrogen ions, H+. The reaction is better represented as hydrochloric acid donating an H+ to water, producing hydronium ion H3O+, and chloride ion. The role of water in this reaction was not shown to simplify the animation. You can think of H+ as a shorthand representation of H3O+.
Okay, so this is just showing you the dissociation of hydrochloric acid, strong acid, fully dissociates. So I've got no bar for the HCl, and I've got a huge bar for H+ and Cl-. So that would be, if you're writing the equation, that would be a single arrow. It's not reversible.
Hydrofluoric acid is a weak acid. Weak acids are weak electrolytes, which only ionize to a limited extent in water. At equilibrium, a hydrofluoric acid solution contains mostly non-ionized acid molecules, HF, and a small amount of hydrogen ions, H+, and the conjugate base ions, F-. This reaction is better represented as hydrofluoric acid donating a proton to water, producing hydronium H3O+, and a fluoride ion. Remember that weak acids only partially ionize in water. The role of water in this reaction was not shown to simplify the animation. You can think of H+ as a shorthand representation of H3O+.
So all this is showing you that weak acid put into water, it'll only dissociate ever so slightly into H+ and F-, and the vast majority of it will be present as HF. So I need to change my share. Go back to this. Okay, so we're now going to see, can we get into the maths a little bit? So Dan, you have to be able to calculate pH for strong acids and strong bases. So we're going to do these together. So strong acids, we've said, are fully dissociated. And if we are to write an equation showing the dissociation, we write it like this. And it is a single arrow that is there. Now, when we are trying to work out pH, you have to know what is the number of protons that are going to be present. So can you name some strong acids for me other than HCl? Any takers? I'm not on mute, am I? No, I'm not.
Sulfuric acid.
Sulfuric acid, so H2SO4. Any other ones?
Benzoic acid.
Benzoic acid is weak acid because it's got the COOH group. So that is a weak acid. It'll only ever slightly dissociate. So the most common ones, HCl, HNO3 nitric, H2SO4, and we're going to give H3PO4. And to determine the pH, you have to know the number of protons that are in solution. So for each of these, there is a different number of protons involved. So if you have 4 rows in your table, I only have 3. So if we go HCl, if we go HNO3, if we say H2SO4, and in our third row we do H3PO4. So how many protons do I have in each one of these? HCl has
1.
1, HNO3,
1.
H2SO4,
2.
2, and H3PO4,
3.
3. Okay, so you remember when we do stoichiometry and there's an occasional kind of weird question where they give us a concentration of, so if we say we'll start at the bottom, we'll do the H3PO4. If the H3PO4 concentration is 0.25 molar, how do I work out the concentration of hydrogen ions? Any ideas? So if up here we write H3PO4 and we're now dissociating it. So this is the 0.25. I'm dissociating it into 3 protons and PO4 3 minus. How can I use this piece of information to work out the concentration of these? Any takers? Okay, try and make it simpler again. If we look at it in terms of the mole ratio, the ratio is 1 is to 3 is to 1. Does that help you now figure out what's the concentration of my protons?
Do we divide the 0.25 by 4?
No. So if we were doing this, Sam, and we knew that in our titration maths, one equivalent is worth 0.25.
Oh, yeah.
What would
multiply by 3?
you multiply by 3? So in some of the stoichiometry, they actually give you this part and they ask you to work out this part. So you're using kind of the mole ratio for this little teeny tiny equation. So if this is the case, concentration of protons in 0.25, this would be 0.75 molar of H plus. So what would it be for H2SO4?
0.5.
0.5, okay, because it's a 1 is to 2. And then the HNO3s, because it's a 1 is to 1, is going to be 0.25 and 0.25. Now you have to be aware when they ask you strong acid concentrations with these two, that there may be a multiplication you have to do before you ever input anything into your minus or negative log to the base 10 H plus concentration. Okay, shall we see, can we start? A question? Dan, you okay? He's disappeared.
Still need a bit more time.
Okay. Trying to see, can I make you guys big? I can only see some of you. It won't let me make you big.
Oh my god, you're gonna shoot us with a growth ray?
That's it. I'm gonna make you all large. I'm only jealous I can't use it on myself.
I think you can move on now.
Okay, everyone else happy? Okay, so we have this part in our single arrow. Why is this twice? So we want to find the pH of 0.2 molar HCl. So you're definitely going to need your equation, negative log to the base 10 of your H plus concentration, and you need to figure out how many moles of this do I have. So my whole solution is 0.2 molar. How many moles of H plus do I have, people? So there's only one H plus in HCl. So what is the concentration of HCl? So I'm trying to get it from this. What's the number?
0.2.
0.2. How'd you get that, Cam?
So, given the question.
It is, well, it's given indirectly in the question. So the question tells you have 0.2 molar of the solution because there's only one H plus. So the ratio is 1 HCl to 1 H plus. Then this is 0.2 molar. So you are now going to get your calculator and you're going to plug it in like this. Now, this is the negative symbol. So the buttons you're going to press are the negative symbol, not the subtraction. You're going to press the log button on your calculator. That is automatically set to the log to the base 10, and you are going to input 0.2. So go mad. So tell me what you got or who got.
Zero 0.7.
0.7. Okay, we happy with that? So it's the negative symbol, it's the log button, and it is whatever the hydrogen ion concentration that you work out to be, and you have to look and see how many H's are in your formula here, because that's going to give you your concentration of hydrogen ions. Okay, so we try the next one. Nope. So bottom of the page now, you have this question. I don't know why this is not going the right way, or why it seems to be multiplying, because I'm going the right way. So 0.4 molar H2SO4. Work out for me, please. What is
What does it mean in the book where it says pH 07 equals 072 pH something?
what page are you on?
142.
So 142. I can't figure out where you are.
pH equals blank arrow pH blank.
Okay, so that was, go backwards, that was pH. So this is what it was. You're filling in this because that's now using your formula. And then your pH, that is your answer. So obviously it goes to 0.7 on significant figures. Is that okay, Dan?
Yes.
Woohoo! Okay, so do we get an answer for this one?
0.1.
0.1. So straight away I'm seeing here, so if I'm going to spread this out, H2SO4 is the same as saying 2H plus SO4 2 minus. The ratio is 1 is to 2 is to 1. If this is my 1, my 2 must be 0.8, and I'm then plugging that into your formula, and it's going to become 0.1 because there's only one significant figure. Happy with that? So if you want to flip over the page, there is one that has a slightly different way in. So you've got to do a triangle first.
This is nitric acid, HNO3.
Nitric acid is HNO3.
Miss, what does it say beside the 2H plus at the top?
Up here at the end.
On the screen, yeah.
So it's say up where I've just underlined, Chloe.
Yeah.
So that is just the plus SO4 2 minus, because H2SO4 will dissociate it into the protons and it'll dissociate into the other ion, the anion.
Yeah.
So how are we doing with this one? What's the first step you should do?
Mass triangle.
Mass triangle. Okay, so if you're doing that, what are you doing? 6.3
Over 63.
Okay. And what do you do next then with that number?
Multiply by 4.
And why do you do that?
because that's only in 250 centimeters and it needs to be in 1,000 because it's per litre.
Perfect. Okay, so I've just done it a slightly different way. I've done converting the 6.3 grams into a litre first, and now I've found my moles. So I've just done it the opposite way, but either way is going to give me the same answer. So my final answer here is 0.4 m. And then so that is my HNO3. So when that dissociates, it dissociates into 1H plus and NO3 minus. So it's a 1:1. So the concentration of my H plus must be 0.4. So then I can plug that into my formula. So I can get away with 0.398 because there's 3 significant figures up here. Are we as content as we can be?
I'm not done writing everything.
Are you able to do them though, Dan?
Yes.
Good. Okay, so for my higher level honeys, while you're waiting, there's 2009, 4F, and 2008, 8A, part 3.
What about your ordinary level?
My
honey?
ordinary level lovelies, I'm going to find you now. I just have to go back out here. Class materials. I thought I'd put that in there for you. Obviously I had not. Okay, just give me a second, because I have homework questions for you. I just want to find where earlier question would be. OneDrive.
Questions for me?
Yeah, I have questions for everyone. Sharing is caring. But I'm going to find you some questions now. All right. Dan, you are going to get me the 2015 paper. See where it is. I'm going to find it a different way. Hold on, just give me 1 second. It's not logged me in. I'm not a robot. So what am I looking for?
What questions do I have to do in 2015?
I'm going to find them for you now. Nope, that is the wrong one. Leaving cert chemistry. Okay. So 7B part 3. And for you. In 2015. 7B part 3. Calculator.
7B free. You sunk my battleship.
Miss,
Yeah.
for 2008,
Yeah.
that's for, do we just make up, well not make up, but choose our own strong base?
So this is the key word. So it's an acid, But that is the key word. So can you remember what this tells you?
Single or
Single.
so one hydrogen in it.
Exactly.
Okay.
So that's why we put that in earlier, because that's the way that they can ask the
Do I
question.
start the question now?
Yes. Yes, Dan. Yes. So
Okay.
you're only doing part 3. You're only doing the maths.
Guys, just one little question. No offense to the question, or you.
None taken. Don't worry. Thick-skinned. So negative log. No. So I'll just go through these 2 higher level questions. 0.03. So it's 2015 ordinary level 7B part 3. Alrighty, so for my higher level honeys, nitric acid is monoproteic, so when it dissociates, it's dissociating into H plus NO3 minus, so it's a 1-to-1, so your concentration is going to be the 0.025. When you plug that in, it gives you 1.6. For down here, they hadn't told you it could be HCl, it could be HNO3, but it is one single proton, so you're just inputting that, and it's going to give you 0.3. Are we happy with both of those? Happiness is? So Dan, where are you in your maths?
Oh, do you mean in the question?
Yeah.
I guess I'm nearing the end.
Okay, so what's your answer?
I didn't get to that part just yet.
Okay, so all we're doing is the maths part of that question, not the whole thing.
Miss,
Yeah.
could you go back to the last slide for a second?
Yep.
Also, I checked the question, and I think it's only math. All of the question you gave me is maths.
Yeah, it is. So it's only that part of that question.
Got it.
So what was your answer, Dan?
I didn't check yet, but I'll round. It's 0. Should I round?
You have one significant figure, so you should give me 2. So what did you put it?
0.2?
No.
0.22.
No. Okay, so I'm going to show you what you do. So Ruth, are you happy? So guys, the homework will ping at 11:30. You don't have to have it done until Thursday. I will show you what it is. 1.22. So there's.
Where did the 1 come out of?
I'll show you now if you just give me 1 second. So the next page you can see worksheet 1. That is going to be everybody's homework. So that there is a number of different calculations there. For some of them you've got to work backwards, so you got to inverse your log.
Wait. By all the class, do you mean me as well?
Yes. So
which work
is worksheet 1, so it's the next page. So everyone then other than Dan can leave, and the homework will ping with the class notebook page at about 11:30.
I've done the non-worksheet homework already.
Okay, well I'm going to show you because you haven't done it right. Is he still there? You're still there.
Thanks, miss.
Okay, so thanks guys for coming back. Apologies.
Thank you.
All right, so Dan, in your question, this is what it said in your question. Correct? So what is the concentration of hydrogen ions that I'm going to have to put into my formula?
0.06.
Boom. 0.06. So that is correct. So if you press the negative, the log, and 0.06, what answer are you getting in your calculator?
Oh, Oh, I just did 0.6. I'm so dumb.
So yeah, you gotta be rigorous with yourself.
Oh, I made it 0.06 and I got the right answer.
Which is 1.2, correct?
Yes.
Woohoo! Alrighty, so are you happy?
I'm happy if you're happy.
I'm always happy, Dan. So look, we will see you on Friday. So you have your exam tomorrow. It'll arrive to you, and you complete your worksheet and put up your photo into your class notebook page, and we will see you on Friday.
Okay.
Bye.
Bye.